Hello guys, we are going to continue with our lessons on introduction to ordinary differential equations. In our last video we looked at classification of differential equations. In that lesson we focused on three main categories in which we can group differential equations. That was the order of differential equation, the homogeneity of differential equation, and finally the linearity of differential equation. Subscribe to this channel for more exciting videos so that anytime I post a new video you'll be able to see. Today we are looking at naming of ordinary differential equations, and in this lesson we are going to look at differential equations and see how to name them. And whenever you are asked to name a differential equation, remember that the three main categories that we looked at will be considered. You check whether that particular differential equation is in which order. After that, you also look at whether that differential equation is linear or not linear. Then later, you look at whether it is homogeneous or not homogeneous. So that is what we are going to look at. So without wasting more time, let's look at some examples. The example here says, name the following differential equations. So the first differential equation that we're going to consider is x squared plus y squared dx equals 2xy dy. So this is what we have over here. We need to name this differential equation. When you consider this differential equation, you realize that we need to put the differential equation in the right form. We have the dx here and then the y here. So let's divide through by the dx. Then let's see what will that look like. So when you divide through by dx, we're going to get x squared plus y squared is equal to 2xy dy dx. So now it is clear for us to easily see. So the first thing that we need to check is the order of this particular differential equation, and we learned that the order is based on the derivative of the dependent variable. Here the order is 1, so we can see it is first order. So here you see that the differential equation is first order. Now we need to look at the linearity of this differential equation. Is it linear or not linear? If you check it out, we looked at three main principles that will help us to know whether a differential equation is linear or not, and that is there shouldn't be any degree to the dependent variable, and also there should be any degree to the derivative of the dependent variable. But here there's a degree to the dependent variable, so it means it is non-linear. The other factors we need not even consider that. So it is non-linear. That's right. Now the next thing that you also need to look at is whether it is homogeneous or not homogeneous. And then homogeneity, we learned that whenever the dependent variable and its derivative are grouped at one side, there shouldn't be any independent variable in it. But here you can see if I move this to this side, become y squared, there will be still x squared over there. Since there's independent variable, and since this is also non-homogeneous. Differential equation. So this is that. So naming this differential equation, the name is this particular differential equation, the name is first order, because in the first order, non-linear, non-homogeneous differential equation. So now let's look at another example. The second example is y prime prime y 2y prime plus 6y prime 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 minus y is equal to x. First of all, as I said, we need to check the order. What is the order of this particular differential equation? You can see that the highest order is what? The y prime prime, and that is the third order. So we state that this is what? Third order. Come on. Now let's look at the linearity. Is it linear or non-linear? Linearity says that the dependent variable, there shouldn't be any degree, there shouldn't be any transcendental function on it. And you can see that all these things, there's nothing of that sort over here. So we can say clearly that this is linear. So linear. Now let's check whether it's homogeneous. Obviously you have this here, so it means it is non-homogeneous. So non-homogeneous ordinary differential equation. So very simple. Example 3. You have this y order 4 equals q at x. This particular function, what this function simply means is this: you know that whenever we have derivative and it's more than third order, we tend to use numbers. But here the difference is that we put the number into what? Brackets. Whenever you see this, you should know that it's what? It is derivative. And this is a function of x, a particular function q of x. So you should know that. So now let's start. Is it linear function or not? Yes, it is clear, it is linear. This has no degree, this is order. Take note, if it is degree, it will be rather y power 4 without the brackets. So since there's a bracket, that means order. So we are going to say that the order is what? Fourth order. Now let's check the linearity. Is this linear? Yes, it is linear because there's no degree. So linear. Is this homogeneous? No, it's non-homogeneous. Because this q at x means there's a particular function q which involves x as independent variables. So it means it's what? Non-homogeneous. Ordinary differential equation. Let's continue. Let's take another example. The next example is y prime minus y prime plus 15xy equals 0. So let's name this. First of all, as usual, the order first. So what's the order of this differential equation? The highest derivative here is 1, so the order is what? First order. Now let's check the linearity. Is this linear or non-linear? For the principle of the linearity, remember that it says the dependent variable must not multiply its derivative, and this is the derivative of the dependent variable, and this is the dependent variable they are multiplying, so automatically it's non-linear. Non-linear here. So this non-linear. Now homogeneity. It says for homogeneity, it says there shouldn't be any independent variable. So when you check this out, this is not independent variable, this is not. And over here, because this is multiplying, it's still not the independent variable. It only become non-homogeneous where we have only the the independent variable there. That's the x over here. So now you see this is what? Homogeneous to the. And then the next example, our next example is y prime plus 1 equals y prime squared minus sine x. Let's check the order. The order is the highest derivative is what? 1. So the order is first order. Now let's look at the linearity. Is this linear or non-linear? Yes, this is non-linear because the principle says the degree of the dependent variable and its derivative must be what? Must be 1. and here's we have degree 2 over here. Hence, it makes it non-linear. So this is non-linear. So we have transcendental function, but the transcendental function is on the independent variable, so it doesn't affect it. That's not the reason why we made it non-linear. The reason why it is non-linear is because of the degree here. Take note of that. Then let's check the homogeneity. Homogeneity says that whenever we make this the subject and this the subject, there shouldn't be any independent variable there. It should be equal to 0. But here's the case: we have 1 here and there's sign x over here. So this is non-homogeneous. So you see, this is very simple concepts. Try this for me. Try this. Pause the video and then try your hands on that. So first of all, let's check the degree. Let's check the order of the differential equation, and you can see that the order is what? First order. So this is first order. Now let's look at the linearity. So the linearity, you can see clearly that if you multiply through by this, you're going to get x squared y prime plus y squared y prime plus 3x y equals 0. So this over here makes the differential equation non-linear, because first of all, the dependent variable has a degree of 2, and then secondly, the dependent variable is multiplying the derivative, hence it is non-linear. It is non-linear. Let's check the homogeneity. Homogeneity, because the x squared is multiplying the derivative, it doesn't affect its homogeneity, so still it's homogeneous. This one, 2, they are all the dependent variables. This one, 2, because there's y attached to it, it's still homogeneous. So this is homogeneous. So thank you very much for watching. This is all for today. Try and solve more questions on that. If you have any problem concerning that, you can draw my attention. Thank you very much. Bye bye.